Hello students, welcome back to Physics with Safdar. Now you are watching IGCSE Physics Past Paper Solution series. In this series we are solving questions of paper 2, 4 and 6. If you are facing any problem in your IG Physics, so you are at the right place. Here you can find the solutions of all of your problems. I suggest you follow the playlist of the channel. Now we are going to solve paper 6, 2021, paper 6 variant 2. Part A we have done before and today we are going to solve part B. So let's start the solutions. This is question number 3. A student investigates a resistor and a lamp connected in series. She uses the circuit shown in figure 3.1. Look at this circuit. Investigation regarding fixed resistor and a lamp, and they are in series. The other components of the circuits are ammeter for measuring current, voltmeter to measure potential difference. Here you can see a resistance wire, crocodile key, power supply and a switch. In part A, the student moves the crocodile key or clip on the resistance wire so that the value of potential difference across lamp is VL and recorded voltage 2.0 volt. She measured the current I for the lamp and resistor in series. She then connects the voltmeter to measure the potential difference across a resistor VR like this. And you can see figure 3.2 and 3.3. Read and record in table 3.1 the value of I and the voltage across resistor shown on the meter in figure 3.2 and 3.3. 3.2 and 3.3, you need to measure current from 3.2 and voltage from 3.3 for resistors, and finally you will write in table 3.1 given below. So let's read what is the reading you can read here through this meter. This is 0, 0.1, and after that you can read the first line is 0.02, 0.12, then 0.14, 0.16, and finally you can read this is 0.18. This is 0.18 by this meter. Look at the second. This is 3. Then start reading 3.1, 2, 3, 4, 5, 6, 7. This meter is showing 3.7 volt. Now you can write these numbers in table 3.1. This is table 3.1. The current you can write here 0.18 and voltage across resistor measured 3.7. Look at this part B. The student repeats the steps in A for values of voltage across lamp 1.0 volt, 0.5 volt. Here readings are shown in the table. Look at this part. It is showing the voltage across lamp recorded with different numbers 2.0, 1 and 0.5. This is the current 0.18, 0.15, 0.12. Third column you can see clearly. These are the voltage recorded across resistor 3.7, 3.0, 2.4. Look at this part. Calculate and record in table 3.1 the resistance of the lamp RL for each value of VL. For this use the formula, this one. RL resistance of lamp, and you can find by using the voltage across lamp and its current. Look at this column. It is showing the resistance of lamp in ohms. If you want to calculate resistance across lamp by using the formula, then you need two things, voltage and current. Start with the first one. The first voltage is 2.0 volt. Resistance across lamp. First voltage 2.0. And what is the first current? 0.18. Divide the numbers, then you get 11.1 ohms. So you can write here 11.1 ohm. Similarly, for the second observation, your second voltage and 0.15. When you divide 1 over 0.15, you get 6.66 by using the same formula. In third case, voltage is 0.5, the current is 0.12. When you divide 0.5 with 0.12, you get 4.16. In the next part, calculate and record in table 3.1 the resistance of the resistor R for each value of VL. Use the value of VR and VI from the table and calculate this one. To calculate the resistance of resistor in this column, once again you need two things. What's the voltage across it and how much current is there. So you can finish your calculation like this. Resistance of resistor, voltage across resistor and current through the resistor. For first observation, this is the voltage 3.7 divided by the current 0.18. When you divide 3.7 with 0.18, you get 20.5 ohms. So you can write here 20.5. Similarly, you can find resistance of resistor by using second observation. The voltage is 3 divided by 0.15. You will get 20 ohms. For third, voltage is 2.4 and divided by 0.12. Then you get once again 20 ohms. Part C1. Describe the pattern of any change in the value of RL and VL decreases. Go back, check with the table. This is VL, voltage across lamp. It decreases from 2 to 0.5. Then what happened with the resistance of lamp? Column RL, check this one. 11.1 to 4.16, it also decreases. So you can write easily RL decreases as VL decreases. See part 2. A student suggests that resistance across the resistor should be constant. State whether your results support this suggestion. Justify your statement by reference to the value from table 3.1. First, you need to write the statement. Check the table one more time. Look at the resistance of resistor 20.5, 20 and 20. The numbers are very close to each other. That's why statement is correct. Correct statement. And what is the justification? because the values are very close to each other. This is part D. A student wished to determine the resistance of the lamp RL when the potential difference across lamp is 0.0 volt. Describe how the experiment can be extended. To do this with the help of suitable graph. If you go back and check the table, so you have done voltage across lamp started with 2.0 and ended at 0.5 like this portion, and at the end of 0.5 what is the final resistance measured across the lamp? It is 4.16. Now you need to know what would be the resistance of lamp when this voltage goes to 0. So look at this, you ended at 0.5. That means you need to take more observation till the voltage becomes 0, and that time you can find the resistance of lamp easily. So you can do this task by plotting a graph VL versus RL like this. Vertical axis and this is the horizontal axis. We are taking voltage across lamp in volts here, and resistance of lamp in ohms on vertical axis, and you would get a line like this. Okay, these are the points recorded from the previous observation, but this time you can read this is voltage is not 0. You can read voltage from here. You need to make it 0 till this point. So how can you do that? You need to take more observation. So you can write by taking more observation. When you take more observation till your voltage becomes 0, so you get your line like this. It makes an intercept on vertical axis that will give you the value of resistance when voltage is 0. So you can write like this. Record RL from intercept on axis when V is 0. Part C. It is possible to use a variable resistor instead of a resistance Y to change the potential difference across the lamp. Complete the circuit 3.4 to show a variable resistor used for this purpose. The voltmeter connected to measure the potential difference across the resistor. First, we need to check what was the first diagram or electric circuit. It was the first circuit, and in this circuit she used a resistance Y to change the resistance in this circuit. Now you need to replace this wire with a variable resistor. So what would be the position of the variable resistor? You need to complete new circuit. So you can complete your circuit like this. This side you can use your variable resistor. You have an option. You can connect your variable resistance to the left or right side. If you connect to the left, then right side you just complete the circuit by joining the connections like this. The second part, you need to connect voltmeter across the resistor. So this is resistor. You connect your voltmeter like this. Question number 4. A student investigates the motion of a ball rolling down a slope. Plan an experiment which enables him to investigate how one factor affects the average speed of the ball. Average speed can be calculated using the equation. Average speed is equals to distance traveled divided by time taken. The task is very simple. That means you need to investigate the motion of ball rolling down a slope like this. This is the slope you have, and this is the horizontal surface. For example, a ball is here at this position, and it's moving down like this. And for this ball, you need to investigate its average velocity. So you need to plan the experiment for this task. And when the object moved from top to the bottom, it covers some distance and it takes some time. So you can discuss its speed easily. And that is the task we have. For that, what you need, look at this part. The operators available includes ball of various sizes and materials, a board which can act as a slope, blocks to support one end of the board. In your plan, you should discuss these points one by one. First, check this point, balls of various sizes and materials. That means you can take a ball of different sizes like this, and it is very clear they have different diameters. So you can write, let's suppose this is ball A having diameter D1, this is B diameter 2, ball C diameter 3, and they are made of different material. Let's suppose A is made of iron, B is copper, and C steel. So you have these three balls. Then you need a board which can act as a slope. So you can see in the diagram, this is the board. You can arrange like this, and blocks to support one end of the board. This side you can use one block that support this board. Now further, look at this part 1. State a factor which can be measured. That means you want to actually investigate the effect of one factor that affect the average speed. If you look at this part, we considered 3 different balls. They are made of different material having the different diameter, and one by one these 3 balls will move on the slope top to the bottom side, and we will calculate their average speed. So one factor we are going to discuss here, that is diameter of the balls. So in this case we will consider diameter as a variable that can affect the motion, and we are going to investigate, and we will fix their masses. That's the condition we are going to use in this experiment. Look at this next part. List any additional operators needed. Look at the formula. When you calculate the average speed, you measure distance and time. For the measurement of distance, you can use a ruler to measure the distance between top to the bottom, and time taken by a stop clock or a timer. Third part, I'm going to discuss these things first, then you will see a written work on the next page. Explain briefly how to carry out the experiment, including exactly which measurements to be taken. It's very simple. You can arrange the setup as I shown in first part. Then what you do, take iron ball having diameter d1, place on slope and release. Then it moves down, and you can record its distance traveled and time taken. In second part, what you do, you take the second ball, copper, having the different diameter, place on slope at the same position as first one, release, measure its distance traveled and time taken. Similarly, for the third ball made of steel, having different diameter, place at the same position on the slope and release, and record its time and the distance traveled. So in this way you can complete your work for this task. Look at this part. You need to answer here, state the key variables to be kept constant. In this observation, what we are doing, we are using the different ball having the different diameter. Of course they are made of different materials, but they having the same mass. That's the key variable in this case. Now you can write all the points from starting 1, 2, 3 and 4 like this. So here you can see the answers of first 4 points. Number 1 was what factor we included here, that is diameter of the balls. Second, what are the other additional operators we use to perform this task? Meter rule for measurement of distance traveled and stop clock for measuring time. In the third part we wrote how you are going to perform the experiment. It is very simple. Place a ball A on the top of the slope at marked position, release and measure the time by using stop clock, and measure distance by ruler. And the same procedure we repeat for the other balls. In the point 4 they ask about what would be the factor you are going to fix here that will not change during this experiment. So we selected here masses of the ball. Of course they have different diameters, but masses we are taking as a constant factor in this observation. The next point is draw a table or a table with column headings to show how to display the readings, and you are not required to enter any reading in the table. Now we are going to draw a table in that you record your observations. This is a table of observation. You can draw a table like this. The first column, name of material, because balls are made of different material like made of iron, copper and steel. Second, diameter of ball in centimeter. D1, D2, D3 is showing they have different values. Distance traveled in centimeter. time taken in second, and finally the average speed in distance traveled by object time taken, that is centimeter per second. The last point is explain how to use the readings to reach a conclusion. So you can conclude your reading by using your observation column. Look at the last column, average speed of the different material. So compare the value of this column, you can conclude your result for this task like this. So you can write a conclusion by comparing results of every speed from the table. So at the end, to make your observation as a fair test, you can do these things. Take 5 set observation and don't push the ball at the time of release. So you would get a fair test of this comparison. Thank you very much for watching this video. I suggest you follow the playlist of the channel. In that you can find all the lessons you need in your IGCSE physics. So keep watching Physics with Safdar for better results in exam. See you in the next lesson.